Hello friends, in this video I am going to discuss some of the essential features of the object-oriented programming paradigm. So number 2 essential feature is data abstraction. Data abstraction. So data abstraction is nothing but hiding the low-level implementation of the service from the users of the service. So I can just write a line and you can just note it down. Data abstraction is nothing but hiding the low-level implementation of a service from the users of the service. So this is called data abstraction. So this is the second essential feature of the object-oriented programming paradigm. So number 3 feature is nothing but the important feature, which is called data hiding or information hiding. Anything you can say. Information hiding is the term which I will use, but it can be sometimes called data hiding as well. Information hiding, by the name it suggests that we are going to hide some information. By the name it suggests that we are going to hide some information or hide some data. So what is information hiding basically? Information hiding is that we will keep some data as private data which cannot be accessed by access from outside the class. So if we declare some data members or member variables inside a class and we keep it as protected or private, they are called the feasibility modifiers or the access specifiers, which we'll deal with later on. Just for the sake of the introductory purpose, you just get the names of what I am saying. That is, some data can be hidden from outside members of the class, and those can be hidden by applying some access specifiers or visibility modifiers like protected or private. If we just keep those data under the protected or private section, we can prevent access of those data members from outside the class, and only the functions which can be declared as in the public section, and they can deal with those data which essentially should be the functions of that class itself, and those functions are called member functions. So information hiding is nothing but we can hide some data by using access specifiers or visibility modifiers like private, protected, to hide the data from outside the class. So this is called information hiding. So information hiding, I will just show you. You will get to know the detail of information hiding and how to implement this information hiding if we write a program or a basic program of C++, which I am going to show you in the next video. I will just give an example of a basic C++ program in which you will just get to know some of the essential features which we are studying in this video. So this information hiding is for the time being, you just imagine it to be we can hide some data by using access specifiers or visibility modifiers like private, protected, to hide the data from outside members of the class or from the outside portion of the class. So This is called information hiding. So another essential feature is nothing but, another essential feature is called polymorphism. What is polymorphism? Poly means what? Poly means many, and morphose means form. Poly means many and morphose means form. So this, from this poly and morphose, this polymorphism comes. That is, polymorphism is nothing but showing different forms. So we can see that we can implement some functions in C++ or in other essential object-oriented or in other object-oriented programming. We can implement the functions to be behaving in different fashions in different situations, depending upon the number of arguments passed to the function, number of parameters that is passed to the functions, and the return type of the function, depending upon the implementation of the function, that is the lines of code which are written inside the function, there is the set of expression statements which are written inside the function, and those can get the function differentiated from other functions having the same name. So that can be called an example of polymorphism, and that essentially is called function overloading. So we will discuss the function overloading in detail in our in some next video, and there are other polymorphism examples, like we have another example, that is operator overloading, by which we can assign some meaning to a particular operator, like plus, minus, binary plus operator, binary minus operator, binary star operator, which can be implemented to some, which can be redefined in some form in order to get them operating between two objects of a class. So that is plus can have a meaning. For example, a plus can have a meaning of addition of two length data, that is expressed in feet and inches, two length data expressed in terms of meter and centimeter. It can also, plus can be also applied for the logic of adding two time data in hours and minutes, or hours and minutes and seconds. So these plus can also be extended in case of addition of complex numbers. So there are different meanings. We know that all the addition operations of time data, length data, having different units and having different representations, and complex numbers, number of addition of complex numbers, they have different meaning of their own depending upon the respective cases. So that in those cases we will get the plus defined in different ways, and that helps us to attribute some different meanings to the same operator plus, and that is the concept of operator overloading, that is plus having different forms. So that is also a case of polymorphism. So poly means many and morphose means forms, so that polymorphism is having different forms that can be applied that can be seen in case of functions. That is called function overloading, and when that is applied in case of operators, that is called operator overloading. So these are called compile time polymorphism, and there is yet another polymorphism which is called runtime polymorphism, which we will discuss in a bit in a overview, which we will discuss as an overview in a bit. That is the virtual functions, and virtual functions is not I'm not going to just describe the virtual functions in brief under this section, because polymorphism I have written. For the time being, you just imagine polymorphism to be function overloading and operator overloading, and please don't go for the virtual functions, that is the runtime polymorphism. I will discuss it in the next point. So this is called polymorphism, excuse me. And another essential features to be dealt with is the inheritance, where the data is where we apply the concept of reusability, and that is called the inheritance. So if you have any doubts and queries pertaining to this section, you can well post your doubts and queries into the comment section below so that I can address them. Thanks for watching this video.